Okay, welcome to the part 3 linear inequalities. These are few sums which we are going to solve. Okay, so first of all we see that this is a mod of 3 minus 4x greater than or equal to 9. So there is a mod concept. First I will write over here. So the modulus, this is how it works. Say mod x is lesser than a. Okay, it means actually x lies between minus a and a. Okay, that means the value of x will be between minus a and a. Why so? You can take some example like say mod x being lesser than 3, so it will be x lesser than 3 and it's greater than minus 3. So minus 3 lesser than x lesser than 3. So how to justify it? Put any values in between. Say if you put 0, if you put 1, 2, it works. If you put minus 1, minus 2 also, it also works, because it turns to, if you put minus 1, it becomes 1, and if you put minus 2, it becomes 2. So this is how this thing is going to work. Now obviously, if there is lesser than equal to, these things will carry the lesser than equal to sign over here. Okay. Now, if I write something like, say, mod x is greater than or equal to a. Okay. So in this situation, okay, I will write not mod x, I will write mod of y. Okay. Greater than or equal to a. In this situation, y is greater than a, equal to of course, but y will be lesser than or equal to minus a. Just follow this thing. If this is 0 and this is a, this is minus a, y reserves this part greater than or equal to a, and it reserves these parts also. This is minus infinity and this is plus infinity. Okay, so this is how it works. So we are given with this sum, so this will go as per this rule. Okay, so if we resolve this, we get two things, that is 3 minus 4x is greater than or equal to 9. Okay, and 3 minus 4x is lesser than or equal to minus 9. Now remember one thing, you have to resolve mod, otherwise you cannot do the sum. So let us do this. So minus 4x, you get a 6 over here. Okay, so minus x is this thing, or if you multiply with a minus, you get x lesser than or equal to minus 3 by 2. Just check out x lesser than or equal to minus 3 by 2. That means it gives you the impression that x belongs to minus infinity to minus 3 by 2, which is included. That means this thing. Okay. Now the second part of the sum that we have to do, this part we will do also. Now 3 minus 4x, so minus 4x, 3 is subtracted, so minus 12. So you get, if you divide by minus 4, so you get a x, you get a 3 over here, but this sign becomes like this. Okay, so it becomes 3 to infinity. So x belongs to 3 to infinity. So when we unite these two answers, we get the actual answer over here, that is x belongs to minus infinity to minus 3 by 2 united with 3, comma infinity. So this is it. Please learn the mod concepts over here which we have seen. This thing, okay, and the above, and this is one of the mod sums. Next we will proceed. So we get another sum of modulus. This has two parts mainly, so we have to first separate it out. Okay, so what I'll write like this, you know, and here I'll write like this. Okay, so this part is like this part. Okay, so when you remove mod, you get it within 3 and minus 3. I hope this is clear. Okay, so when you do it, you add plus 2 to all these things, so you will get plus 2 means only x. So if I do a plus 2, I will get a 5. If I do add a plus 2, I get a minus 1. Okay, so x is between minus 1 and 5. Okay, so let it be. So this is the thing. Now let us consider this one. So this means actually this thing. Okay, that one. So first of all we write that x minus 2 it's greater than equal to 1. So that will give you x greater than equal to 3. Now x minus 2, so this is 1. X minus 2 is also lesser than equal to minus 1. Okay, so that is going to give you something like, if you add plus 2 with this, so x is lesser than plus 1. Okay, so here if we combine all these three, say this is 3, so let us draw. So what we see over here, what are the points? I get a 1 over here, so I plot a 1. I get a minus 1, I plot a minus 1. I get a 5 over here and 3 also. Say 3 over here and 5 also. Now minus 1 to 5, it indicates that there's a dark till 5. So this is the solution of 3 you get. Now if you take 1, x is greater than 3, equal to 3, greater than equal to 3. That means if I mark it, it's like this. Okay. Now if I mark this, x is lesser than equal to 1. That means, now see all the common region. Which are the common region? So this will be the common region. This will be the common region. This to this. So what are the common regions? So common solution minus 1 to 1, and that is closed. Why closed? It can be lesser than 1 but more than minus 1. So this region is satisfied, united with also 3 to 5. So this will be the solution answer for this. Please see if you have any confusion regarding this. So the common region of the intervals are considered over here. So let us move to the next one. So we see another sum over here, 1 by mod x minus 3 lesser than equal to half. So here we immediately take the reciprocal of this. You know, as per the first rule, if I take the reciprocal, the sign will be changed. Okay. So that means immediately it gives you the idea that mod x will be greater than equal to 5. So that will give you the idea. This is about the second part, second this thing. So x is either greater than equal to 5 or x is lesser than equal to minus 5. Okay, so if you write the solution, it will be something like from minus infinity to minus 5, it's open closed, okay, union 5 to infinity. So x belongs to minus infinity to minus 5, open close interval, union with 5 to infinity. Now this sum is a very typical one. If you look at it, it's 0, it's 5, here it is a minus 5. So it's very fine that if you put some numbers over here and check, after 5 or below minus 5, it becomes, the number increases. So that means, say some number like 7 or 10, if you put, you get fractions like 1 by 7 or 1 by 8 like that, which is always lesser than equal to half. So that means this part is taken care, it's satisfied. Okay, so we can say this as per the solution already we got. Now another thing is also there. Okay, so as of this situation, you must understand, look at the denominator. The denominator is something like mod x minus 3. So it could be, from the fraction perspective, it could be negative also. So why it could be negative, I tell you. So it's like this, it could be negative also, okay, but not equal to 3. That's why I have not written equal to sign. Okay, so why it could be negative? Because if you put some numbers like, so this is another clause. So mod x I'll first do and then I'll explain. So this gives you another fact that x is between minus 3 to 3. That means here if you take 3 and minus 3, so this range is also there. This part is also there. Why so? Just try putting 0 over here. If you put a 0, what you get? Minus 1/3, which is lesser than half. Okay, so that is satisfied. Now if you put, say, minus 1 over here, then what will happen? Or 1 over here. Say any numbers from this region, 1, say 1, if you put, you get what? You get, it's minus half. Minus half is lesser than half, so that is okay. Okay, so that means the answer, so this part is really very important. This part gives you the extra condition, which is really very important, which has to be merged with the sum. So it's a minus infinity to minus 5, which is kind of this. And okay, note one thing, that it should not be equal to 3 or minus 3, because if you put equal to 3, it becomes undefined. So it should not be equal to 3. Union with minus 3 to 3, open, union with 5 to infinity. So this is the thing. Okay, so this is the answer for this one. Let us proceed to the next one. Okay, so we get another sum over here. So that is this one, mod of x plus 1 plus mod x. Okay, so here we see that individually, if you solve this, you will get x equals to minus 1. So x plus 1 is equal to 0. So x equals to minus 1 is the break point. And this will be kind of what? X equals to 0. So if you consider the number line, you get the breakpoints as minus 1, 0. Okay, so there are three regions. There are three regions of modulus. So what I will do, I will break the cases as case 1. Okay, so what is case 1? Case 1 is this part. That means minus infinity to minus 1. So I write over here x belongs to, or rather I will write like x lesser than minus 1. Okay. So lesser than minus 1. Lesser than minus 1. So if it is lesser than minus 1, then what happens? This turns out to be negative. This turns out to be negative because minus 1 also it becomes 0. So, but if it is lesser than minus 1, say anything like minus 2, it turns out to negative. So this also. So it becomes minus of x plus 1. You know the mod property. This is minus x, so greater than 3. Okay. So here you get it's minus 2x minus 1, which moves to this side. So that becomes 4. So here x greater than minus 2. Okay, x lesser than minus 2. X will be, if you divide by minus 2, the sign automatically reversed. So it becomes lesser than minus 2. So here we can write that x belongs to minus infinity to minus 2. Now case 2 if I do, that means it's within this part. This is case 2. So that means x is greater than equal to minus 1 and lesser than 0. One thing you must note that whenever I am writing x in an interval, I am writing lesser than minus 1, lesser than 0, like that. Okay. So in this way, if it is equal to or more than this, the first mod will turn to positive. Look at this. This is minus of x plus 1. This is plus of x plus 1. But the second mod, since it is negative, it will be minus x. Okay. So here when you cancel it, you get 1 greater than 3. That means this kind of solution does not exist. So 1 greater than 3, from here we don't get any feasible solution. Okay. Now after this we do a case 3. Now case 3 is this part. Okay. So that means here x is greater than 0, or we write like this, greater than equal to 0. That means it's more than 0. If it is more than 0, both of these two will be positive. That means we get x plus 1 and x greater than 3, which is 2x plus 1 greater than 3. 2x is 2, so x greater than 1. Okay, so x greater than 1, if you see, that means x belongs to 1 to infinity. Okay. So this 2 will give you the answer. This 1 and this 2 will give you the combined answer. Therefore, x belongs to minus infinity to minus 2 union 1 to infinity. So this is the answer. Okay. So this is all with this part. Thank you.